Hi everyone, welcome to lesson 3 of the digital drawing classes. This week we'll be looking at advanced tools in AutoCAD. I must say really quickly that I'm recording this from a building site, so there may be some banging or dogs barking in the background, but hopefully it won't interrupt the lesson. So lesson 3 is advanced tools. During lesson 1 and lesson 2 we looked at the principal tools that we need to use in order to draw a plan. So you can see here line, polyline, shapes, trim, move and copy. And then in lesson 2 we recapped the basic tools in order to draw a plan that we have hopefully saved. We're going to carry on using that plan today, but if you haven't saved the plan, then what you can do is draw a line or draw a series of lines, not necessarily resembling a plan, before doing the actions that we are undertaking today. So the actions are the most important thing, not the plan, but obviously if we've saved the plan, then it makes things a little bit easier. So today, if we're thinking about using AutoCAD as almost learning a language, we've begun to learn some tools in lessons 1 and 2, and obviously those tools are like learning words, and today we're going to expand upon those tools. We're going to look at some of the more advanced tools, and hopefully they will improve our vocabulary when it comes to AutoCAD, improve our ability to draw plans, and by adding some additional more advanced tools into our range, then it means that we will be able to draw better plans easier. So if we go down into AutoCAD, we'll be doing something like this today. So we will be hatching walls, we'll be creating arcs, we'll be curving the edges of walls, and stretching and scaling as well. So if I go through here, you'll see a kind of reverse of everything that we have done so far. So we will be working on breaking, joining lines, creating arcs and fillets. I'm just doing this in order to get us back to where we were. So this is what you should have, something relatively similar to this. And obviously in previous weeks we looked at draw tools up here, we looked at modify, we looked at setting up our workspace down here, and today we're going to be looking at some more tools in these two bars. So a couple more of the drawing tools and a couple more of the modifying tools, and then we'll be looking at hatching. So in terms of an introduction to the other tools that we're going to be using, one of the things that we talked about either last week or the week before was that when you clicked on a line, these little vertices appeared, so vertex, stretch vertex or add vertex, and if you click on one, you can stretch the point of a line to Control Z. If you click or hover over the middle, you can either stretch, which just pulls the whole line. You can add a vertex, which you can see here, adds another point in the line, or you can hover over and convert to arc. So that's one way of creating an arc that is relatively controllable. It means that you're able to draw a line, the distance that you require, and then convert it into an arc. One of the things that's really important when we are doing an architectural drawing is that we have control over what we do. So the benefit of using AutoCAD is that we can be very specific about dimensions, and we can also control the information that we create, so that when we are communicating our buildings to other people, we have confidence in the information that we're sharing. So that is one way of stretching, just by clicking on a line and pulling it across. Sometimes I find in practice a very helpful thing is to be able to stretch an entire part of a drawing. Now, last week and the week before we talked about selecting. So if you, with your crosshair, if you just hold down and keep holding the mouse, you have this selection, which means that you can draw where you need things or where you want things to be selected. We also talked about having the selection from top to bottom. It's a blue box and things need to be entirely covered before they get selected. And we also talked about the bottom to top selection, which is the green one, which is where as soon as an object is touched, it becomes selected. Now we can use this selection from click bottom to top to highlight a wall that we would like to stretch or an area of a plan that we would like to stretch. We're going to make this entrance room bigger. So if we click, and now we can either go over to the stretch tool, which is here, or we can type S for stretch. We've selected our wall. Obviously this is a modify tool, so we need to tell AutoCAD what we want to modify before we tell it how we want it to be modified. So we've selected the wall, we've come over to stretch or pressed S and hit enter, and now it says specify base point. If you click anywhere on the plan, see you can pull the plan down, you can pull the plan across. You can see because of the polar tracking that we have set up that it snaps to easily defined vertical and horizontal and 45-degree lines. But for this, I'm going to stretch it down. And like with every other tool, you're able to input a very specific measurement. So if you type in 1000 and hit enter, we have stretched this wall by 1 meter. If we have stretched this window accidentally, then we can do the same thing. Click, bring it up, select this little part of the window, click S, enter, and then we can stretch that back up. And I'm going to stretch that back up 1 meter, so that's 1000, and hit enter. So that's the first tool today, is stretch. You can do it for a wall. We could do it for a part of a wall. We'll make a wall thicker if we want by 300. So I've just made this wall particularly thick. Or we can make the room bigger. But that is quite a useful tool when developing a plan. Now, I briefly touched upon creating an arc by selecting this line and hovering over and converting to arc. That's one way of creating a curved line. We had a couple of questions last week with people struggling to control how they did curved lines, which is obviously an important part of architecture. There are 2 tools that we're going to look at to curve a line. This is the first tool, which is up here. It's arc. And then the other tool is fillet. Fillet rounds off a square edge. So if you have a corner that you want to round off, then the fillet tool could be the one to use. We'll start by using the arc tool, and you can see here that whenever a tool has a light grey arrow, if you hold down on that tool, it gives you lots of options. So it looks as though there are about 10 options for drawing an arc here. Now if we start with the top one, arc 3 points. Underneath the crosshair, as ever with AutoCAD, it gives you the directions on how to use the tool. So it says specify start point of arc, click, and then I'm going to click the second point, and you can see that it's creating an arc, but you can see how uncontrollable this arc is and how difficult it is. Imagine trying to draw a smooth, neat arc with that. It's kind of impossible. So I'm going to escape that one because I don't think it's a very useful tool. The one that I have found works the best is arc start end direction. So if you click on that, What this one does is it allows you to specify the start point, specify the end point, and then specify the angle at which we draw the arc. So the next thing to look at in regards to an arc is having looked at all of these options and decided that I think start end direction is the best tool to use. The other way of drawing an arc is to curve an existing corner. So you can see here we have a corner of a wall. It doesn't necessarily need to be part of an existing wall. It could be two lines, it could be any part of a drawing. They don't need to be 90 degrees either. You can round off a corner by using this tool, which is the fillet tool. And you can see here, if you click the tool, it says select first object all. And if we click on the down arrow, you can choose the radius option. Now the radius option allows you to specify the radius or the size of a curve. So if we click radius, and now it says specify fillet radius. So I'm going to say 600, because I know that this wall is roughly 600. And then it says select the first object and select the second object, and you can see that it is rounded off that edge. So if we do that again, what we can do is we go over to the fillet tool, click, and then select first object or radius. And I know from memory that this wall is 300 millimeters wide. And remember, we always work in millimeters. So this time I'm going to specify the fillet radius as 300. You can see it remembered the 600, but we're going to change it to 300. And if you hover over first line and then select the second, it rounds off that edge. So that is another way of creating a curve. Now, one thing that may be useful, and you can see when we first drew these lines, lots of them were part of the same object, like a rectangle like this. And if we select the rectangle now, you can see it's all part of the same shape. But as we've chopped and changed and rotated and copied all of these lines, you can see they've all become separate lines. Now that's absolutely fine in terms of drawing a plan, but sometimes you want all of these lines to be part of the same shape. And the way that we do that is to use the join tool. So you can either type in join and hit enter, or you can find the join tool over here in modify. So either way, either type in join and hit enter, or select the join tool. And what it says is it's select the source object, so all multiple objects at once. So you can select multiple objects at once, or you can go around and select individually. And when you've selected everything, if you hit enter, it creates a unified shape. Now that is, like I said, not necessarily the most important for general use, but it can be useful when looking to use tools like offset, which is here, which is something that we tried to use last week or the week before. So now if we type in offset distance, it says select offset distance. We've already selected the tool. Now select the distance 100 and hit enter. You can see that we're able to utilize tools like offset because we have made this part of the building a single shape. I'm going to delete that because it's not necessary for our building, but it's just it's an interesting thought about how we may need to join some lines in order to activate some of these tools, be able to use some of these tools. You can see what happens if I select 100 on some of the areas that aren't unified. You can see you have to do it for every separate face and offset individually instead of having the kind of smooth, complete offset that happened when we did this. So
One thing that we need to remember is joining lines is sometimes important when we're developing more complex plans. Another thing to cover is the break tool. So very similar to the arc tool and the fillet tool, where we have two ways of drawing a curved line. We have a couple of ways of trimming a line as well. So if we go TR for trim, we remember that we can select one object and then the other, hit enter, and trim. So TR, enter, enter. And you can see you can trim this way. The other way of trimming is to use the break tool. So we can start to type in break, and you can see BR is the shortcut. So if we click on that, you're able to, I'm just going to zoom in, you're able to break a line that way as well. So that is sometimes a useful tool to be able to use. So as well as trim, you can also use break. Now, one thing that we will look at in much more detail in a couple of weeks when we look at Digimap is how to scale an object. But as a very brief introduction, we will draw a rectangle now and then use that to scale an object. So I'm going to pretend that I'm drawing a door here. I'm going to start drawing a door, but I don't know how thick it is or how big it is, so I'm just going to do a rectangle. Now there are a number of ways of scaling this rectangle so that it fills this space or a space. The first thing to do is to select the object and then come over to modify, and you'll see here is the scale tool. And it gives you the instructions how to use it. So it says specify base point, which is the point at which the object will either grow from or contract to. And then it says specify scale factor, or you can just pull your mouse. Now you can see I've pulled the mouse and it's gone kind of crazy. So pulling the mouse is never the most controllable way of defining scale. And as we've said, having a degree of control over what we draw is why we use AutoCAD. So the first one was scale factor. So if we type in 2, you can see the rectangle has doubled in size. If we select it and type in SC for scale, instead of going over to the side toolbar and clicking, specify the base point, so the same base point, and we can do a scale factor of 0.5 and hit enter. That's made the door reduce in size by half. So you can type in any scale factor. If we typed in 100, it would get 100 times bigger. If we typed in 0.1 or 0.1, then the door, this rectangle, would get a tenth of the size. But you can see both of those. If I scale and then hit and then type 2, the door has gone over this line now. So that's it's difficult. It's good to know the scale factor. It's a very easy way of growing something by a specific size, but it's difficult to make it match perfectly because you'd have to do a bit of maths to be able to work that out. So the way of making something stretch to fit in a proportional way, obviously we did this before where we highlighted the rectangle, pressed S, enter, and then pulled something. That's one way of doing it, but that's not stretched proportionally. So we've just pulled the rectangle across. That's fine for a door, but it may not work for other shapes. The other way of scaling is to select the object, click scale, and then instead of, as soon as we select our base point, instead of scale factor, there are other options. One is copy and the other is reference. So copy would keep the original and then create a new shape of a different scale, or reference. And in order to select reference, you can either click down or you can just type REF to tell AutoCAD that you want the reference option and hit enter. What this allows you to do is it allows you to select your base point select another point on the shape and then stretch the whole thing across. And you can see that it's growing proportionally and it should snap. There you go. So that is a way of scaling an object. And what I'm going to do now is I'm going to just show you the difference between the stretch that we did before and the scale, just so you can see them properly. So I'm going to copy over these two. So what we did at the start of this lesson was we selected a part of a shape or a plan, clicked, pressed S for stretch, and then pulled across. That's a non-proportional stretch. And the other option is we select the object, we type in SC and hit enter. So let's specify our base point, which is the point at which the shape will grow from or contract to, and then type in REF for reference, and then we can click first point, the second point, and you can see how this time the shape is growing proportionally. So that's the difference between stretch and scale. You can imagine that this may be a digimap, a PDF, or an AutoCAD drawing that we have imported and we need to blow up into the proper scale. And we'll look at that in more detail properly in a couple of lessons' time when we look at digimap and importing information. But at the moment, that is stretch and scale, both of which are quite important tools. I'm going to select both of those and delete them so that we can move on to the next object and the next tool without any complications. So we've looked at some more additional tools here. We've looked at some more modifying tools down here. The last thing that last major tool that we haven't really used yet or looked at is hatch. Now we've looked at some plans previously, and everybody will have seen plans where the walls are filled in, and obviously you've seen plans where walls are empty like this. The way that we fill in walls without using Photoshop or any other Adobe software is by using the hatch tool. So if we click on hatch, this box will appear. It may look slightly different in different versions of AutoCAD, but it should have these tools. You can see that we can select the pattern. This is where we select the angle of the pattern. So this is a 45-degree line at the moment, but if we wanted it to be slightly different, we could change it here. This is how we can modify the pattern scale, so how close or tight or far away the lines are. So if we, first of all, click on this down arrow and open library, you can see there are lots of different types of hatch. So you should all have inbuilt lots of a library of hatch types. You can see that there is a cross hatch, there is the line, we have a solid hatch, we have brick, this looks like a roof tile, concrete, so there are lots of different types of hatch. We're going to go for the top hatch, the most simple, this diagonal line. It's already chosen. So then we have our hatch chosen, we're on the hatch tool. It says select objects all. And if we click on the down arrow, you can pick internal point. And this is a lot like a paint bucket in Paint or in Photoshop. So you can see if we click on it, it fills in the hatch, and hit enter when you're happy. So you can see we've filled in these shapes with a hatch, and you can see if we'd have put the paint bucket here, it would have tried to fill this whole space. So when you're using the paint bucket, it has to be a closed space. It doesn't have to be a joined shape. It doesn't have to be like this. It doesn't have to be a perfect shape, but it just has to be a closed shape in order for the paint to flood it. You can see that the hatch is incredibly tight. We chose a striped line. If you see, it is a striped line, but it's very, very, very tight. So when we zoom out, we can't see it. What we can do is if we select that, we can select multiple at the same time if we want. You can change the size. So let's make it 300. Here we go. So that's much more visible in terms of a hatch. If we select this, and change it to 25. You can see we can change the angle if we want, if we're not happy with the angle as it is. I'm going to keep that as it is at the moment. And what I'm going to do is I'm just going to delete this hatch for a minute to show you a couple of things. The first is that I drew a perfect arc, but now it's faceted. So now it's a very simple arc made of 8 lines. AutoCAD does that in order to help save your processor. So in order to show your actual arc as it is, you can type in RE, which means regenerate, and if you type in enter, so RE, enter, it will force AutoCAD to show you what you have actually drawn. And the next thing is that if we select on this hatch, we can do exactly what we did with our lines to the hatch. So the hatch is adaptable. We hover over this middle point, convert to arc. We can do exactly the same as we did with our lines with the hatch. Now that's one way of filling a hatch, which is to flood it, pick internal point. Another way is if instead of pick internal point, if we select objects, you can just select an object, and this was obviously a joined object that we created, so that filled really nice and easy. We could select multiple objects by using the rectangle selection, and that will also fill. So this says the specified hatch pattern and scale will create a dense hatch. Do you want to do? What do you want to do? So I would just press automatically fill, and then we can change the density, the scale of the pattern later. So we said 300 worked well. Here we go. And if we change this to 300 as well, what we can also do is we can select a hatch and then go, this toolbar will open, go to the library, open the library, and we can change it for another hatch. We can change it for any hatch we like. So I'm going to open the library again, and I'm going to create this one as concrete. That's really big concrete, so I'm going to change the scale of that. So 300 is obviously too big for this pattern. 30 is a lot better. So you can see that we've filled in 3 of the walls with different hatches. If we really like one of these hatches, what we can do is I'm going to delete this. If we really like one of our hatches and we want to replicate it in other areas, we can use this tool up here. It's an eyedropper or a pipette. So if we click on that, we can select a hatch that we like and then infill it somewhere else. So that is the third way of managing a hatch. Now, in the Q&A a couple of weeks ago, we had lots of people talking about line weights, about layers, about line thicknesses and colours. We will do all of those things in the next lesson. So you see here, this is lesson 3. Lesson 4, we will be looking at layers, line weights, how to create a plot table, which is really important for printing, and how to print a PDF. So all of those things are really key, but I think for lesson 3, it's absolutely fine that all of our lines look and feel the same. But obviously, as we become more advanced with AutoCAD, we will begin to need to define the difference between this as a wall and this as a window. So we will want these walls to be thicker and to print as a thick line, and we will want these walls to be thinner. And we may even want, within AutoCAD, to differentiate this as a wall from this as a window, so that it's easier for us to begin drawing quite a complex plan and to be able to see the difference between what lines signify. We do that using all of these layers, all of our colours, whether a line is continuous or dashed, whether the line is thin or thick. We will look at all of those things next week, and I think that when we add in the tools that we've looked at so far, with an understanding of how to use layers and line weights, we will get to a point where we're able to start drawing our case studies and drawing them well with good line weights and good CAD management. So we'll be doing that next week in lesson 4.